What up, class? This is Gerard. You guys can call me Jay. I like to do videos instead of just typing out stuff, just getting that out ahead of time. It's a style that I've kind of adopted just because I noticed that a lot of people have kind of like an audible kind of learning style, including myself, or a video style. So it also makes it so that if I have something, I can show you right here on demand. I will do a little bit of a write up for this discussion post, but I usually just like to talk things out so that way I can convey my thoughts a little bit more clearly, and so people can, I guess, kind of pick up what I'm trying to express out in thought. So, with that said, doing a discussion application performance. Um, I mean, this we're definitely talking about software for sure, or how an application handles processes so that it makes things easier. This can be done or taken quite literally in almost anything. Application in a business, software, school, kind of a deal. Um, Tools, for whether it's automotive or whatever. But um, the application performance that we're going to be talking about, I came up with two. Um, the original question is, why is performance in applications so important? And then find two examples where performance has been optimized because of application requirements. I chose two. My first one is actually one of my favorites because I'm a huge vector fan when it comes to coding. Just because, especially in C++, they're just so dynamic. Let's see. Let's pull it up. And here, I chose Pandora. Pandora, the music application, is quite unique. Um, Basically, they have something called the Genome Project, or sorry, Music Genome Project, which is a huge cross-referencing data structures and all that stuff. But basically, it's 400 musical attributes right here. Some of them are professionally sought out, and they have professionals sit down and be like, "Oh, the pitch of this is crazy." But it goes from anything from pitch to genre to types of instruments to preference to artists, names. 400 attributes. You can imagine. Some of them are crazy. Um, Date it was created. And then basically they load this up into a vector 400. So for those of you who are familiar with vectors, you probably see them in Unity for game programming people. And basically all that is taking three elements and in Unity's case, three variables, popping it into one so that as your item is moving with your vector 3 in a 3D game, it's correlating all three of those at the same time to translate your position, right? Or transform your position. Um, how they use it though in Pandora is quite different. They have vector 400s, and that is in, I think it's in this one, uh, the approach. It's definitely in here, but they use a vector 400 to basically list out this huge number, this 400 attributed number, and how Pandora figures out what is next in line, what's a music that you would potentially like is the number that is given. So we'll just do a three vector right here. We're going to shrink this 400 number just for an example to a vector 3 again. Right, and it's saying I like classic rock. So is this song classic rock? Give it a 1. Is this song um, give it a 1 for like true, or is this song have a guitar? Give it a 1 for true. It's got a guitar. Does this song have a flute in it? 0. No, it does not have a flute. So you get this long number, right? And the list goes on with the attributes. But for this small example, um, the first one has it's classic rock, it's got a guitar, doesn't have a flute. So then it's going, all right, what songs would you like next in this? And it is going, well, he likes classic guitar, so let's see, what songs we have. So it's going to look for a song that it's got classic guitar, it's got rock, so 111. This one also has a flute. This has got a 1. That might be the next one that he likes. You never know. And then based on whether or not you click, like or dislike, it'll change your settings of what songs you would like as another attribute added to the musical vector here. Another one, it would be like, so he's definitely not going to like something that's not classic rock. It has a vector value 0, that doesn't have the guitar 0, and it's got flute 1. So that would be very far. So it would pick the next number in line that's closest to the number that you're actually listening to in a vector format, um, to decide what you're actually listening to and what you potentially might like. So that's why you're not listening to the classic rock station, then all of a sudden, out of nowhere, you've got random R&B, or you've got some classical yodeling folklore music popping up. If you choose a station like that, it's going to start putting you into a different vector number and start off of that. Not to say that you can't have some random music out there with it, but for the most part, that's how it's determining um, whether or not you're going to enjoy the next song. Is it's taking the number, the 400 vector number that you have currently, and it is comparing it to the next one above or below. And then once you're listening that one, it's going to compare to the next closest one above or below. Obviously saying, oh, well, he's already listened to that, so we're not going to put that one up again, within a reasonable amount of time. But so that's just how Pandora utilizes vectors, which I think is a very outside of the box way of thinking to use them. I also think Unity's outside of the box way of using them. It's just kind of interesting to see on how um, basically vector in the C++ is just a list. So that's just kind of, it's a list that you can add and subtract to constantly, but still have as one entity, which is amazing. And that's how Unity really uses it. It's one entity or affecting three different values at the same time, which is how it gives you the move value. Um, but I just thought that this was one of the unique ways of optimizing performance using data structure of vectors. Um, which I guess could kind of fall into the array aspect of coding. I apologize. I was doing a lot of talking, not a lot of breathing. But yeah, this is quite an extensive article. Um, they have thousands of songs, and each song's got 400, so it's got so many variables. So the way that this optimizes it in the end is you're like, well, how does this optimize it? Is you're using one entity per song. Granted, you have to get the original core numbers, which is kind of a pain. I think it said it took them about 5 years using professional help to get this genome project down, which is basically assigning these attributes to these songs. And then obviously new songs come out every day. But um, instead of making 400 variables constantly, for each song all the time. Now each song just has one vector 400 that it can use and relate to and be compared to. And in a code sense, this is much quicker than going through each variable for each song and just doing that. Like comparing, is this rock, is this jazz, does this have blah blah blah. Now it's just going, all right, index 1 is 1, index 2 is a 2, index 3 is a 3, and the rest don't match, so we're not going to play this next song. It also makes it so that you can list and store the data of the songs a lot better with memory usage as far as the program goes. But I just thought that that was a unique way for Pandora to use their stuff. The second one, where is it? Boop. Ugh. Yep. Okay. Pardon me again. The second one I did was Facebook's and their social graphs. Um, Facebook is obviously huge, social network, and the biggest problem that Facebook I've noticed that they have encountered is um, assigning a tag or assigning a component something new. so that way it can identify what's actually being done into your into your profile and how it can display things back to you. So um, their goal here for the assignment problem. So assigning objects to system components is a challenge. That's basically their issue. Their requirements is obviously they want minimal average query response times. They want load balance components. So better balanced load components. They basically want it to be more efficient for this loading process. Um, the assignment stability, so that way things aren't overlapping or basically becoming jumbled garbage. And then obviously, so if you do something, they want it to be fast when you look something up, right? So, I mean, in the end, somebody looks at something, they assign it, and then somebody can use that tag or that hash and bring it up and be like, all right, cool, because hashtag. This is basically the hashtag, awesome things kind of um, uh, function or feature to a lot of the new social media stuff, um, where you're assigning something to an item. Ooh. You're assigning something to an item and then being able to use that as somebody else to bring that up quickly and efficiently. This takes a lot of work, though, obviously, and they've got the reasons here scale, um, the similarities on the load balance, dynamic workload, the addition and removal of objects. That's a huge one that I could think of that I thought of right away. And basically, all you're doing is you're basically loading, um, not loading. What would be the word? You're basically taking an item and you're just giving it new names and new ways to find it. Basically, if you think of it as a house and you're giving it constantly different addresses, multiple addresses, new addresses, some new doors on how to access it. And so it's being so rapidly changed all the time from such a big or from such a large number of accessibility that it's just hard to, if you were to think of that house, the structure of it, and trying to find it would be a nightmare because you don't know what is the current address, you don't know which door you're supposed to use, you don't know what the structural framework of it would be. Is it falling apart since we've had so many different changes to it? So that's how I viewed this framework, and how they do it is just basically by using the network framework and then the social hash framework, which is basically just giving it temporary um, kind of pointers to it. But I mean, in the end, you want to keep something like this together because at any point in time, any change to it, if it's permanent, could drastically alter what it's doing inside of the program or the algorithms that they have there. Also, you want to make sure that the um, just the accessibility of it doesn't degrade what it actually is to both us as users and to both the program as it accesses it nonstop and changes it. Plus, you gotta think that um, the way that the hashtag, sorry, why can't I not think of the words right now? Boop. I'll go back up. The social hash framework works is so that it's designed to be for quick access, quick lookup. So it's trying to be as efficient as possible with all of these changes to some things due to the mass scale of accessibility throughout social media just in general. This is using Facebook as an example, but think about Twitter, you think about, oh man, just Google, I mean, I don't think Google uses I think you use hash in the Google, but all those other, what is it, Instagram, all that craziness. But this social hash framework, I think, has um, made it so that you can definitely use these search dynamic features a little bit more. Here's some more graphs to it. It's you know it's an algorithm. It's pretty unique, but um, they have tons of different algorithms in here. I can't even cover it. The static assignment algorithm. Um, that one was interesting. Dynamic assignment is good, uh, but the social hash seems to be what they use the most, and it's actually what is easier and reduces the application's time and requirements to actually do the function that it needs to do, so that it can meet the load balance. It can meet the average query response time, faster lookups, stability, and all that stuff. Stability is huge, especially just in this massive network where things are changing all the time. Huge, huge. All right. Well, that's what I got. I will put my resources down here, just like everybody else. But I hope you like this little bit of a change, other than just the text deserts. I'm not a huge fan of those, but some people might not also like listening. But either way, just leave me a review, just comment. I like to interact, and don't be surprised if one of my replies is also a video, just because I like to talk to people. So to me, technology is here so that we can communicate easier and at a more comfortable level, and so this is how I use it. But all right, thank you everybody, and have a good evening.